thanks to AGI and the other sponsors of this webinar. When we conducted this series of talks on Capitol Hill in the Capitol Visitor Center on June the 22nd, there was a full room, and you all did a great job of organizing it and getting the message out. And I think that the talks that you're going to hear this morning were great examples of the diverse value of data to society, and focusing here in the United States. As the first speaker at the briefing, I was asked to set the context on data as a national asset. I began with just, about the USGS role as the nation's Earth Science Agency, which is mostly what we're going to focus here. But our focus at USGS is on natural systems, both the biological resources and the water, energy, minerals, and those other sorts of natural resources as well, and natural hazards. And at USGS, I think anyone in the building here would say our reputation is our most important asset, and it is dependent upon the quality and integrity of our science, including our data. The group I work with, the Climate and Land Use Change Program Mission Area, with our climate science centers and close ties to the Fish and Wildlife Service and Park Service, we recognize that natural resource managers in a changing world need credible, timely, actionable science and data that is built on information and data from trusted sources. My appreciation for data as an asset upon which decisions could be made began when I served at the state level as director of the Louisiana Department of Wildlife and Fisheries many years ago. The resource management decisions that we labored over the most, and a few times regretted, were those for which we had no data. I remember one time walking into the Capitol during the spring session, and the president of the state senate was at the podium instructing our department on when to open shrimp season one year. Fortunately, we had history of using salinity and temperature data to project the growth of shrimp in the estuary, and we were able to do it according to what the science projected would be the maximum harvest for the shrimpers, and we were able to stick with it. If we had not had the data, I may not have been successful in maximizing shrimp growth and or the harvest, which would have affected thousands of people in our state and their families, the shrimpers and their families. As a member of the Gulf of Mexico Fishery Management Council, I remember setting seasons on bluefin tuna with very little information about the status of the stocks or understanding the migration patterns and fecundity, all those things that we needed to know to regulate and prevent the collapse of this highly migratory, much sought after species. We did much better on redfish and speckled trout, creel limits and quotas because we had data. And these two species, speckled trout and redfish shown here, bounced back pretty quickly after a few years of some tough regulatory decisions and enforcement that people now celebrate as a restoration of that fishery. I learned quickly that data was an essential foundation of decision making. I learned that it was the integrator and the common denominator for discussions that allowed the public, the users, policymakers, regulators, and scientists to work over a table together and make decisions that affected the sustainability of our state's natural resources. Generally, I found it was that when people had access to the same data and understood the trends in the resource information and the projections that were based on that data, they could reach agreement on what was best for the resource. As manager of our Coastal Zone Management Program for the state, a few years later, I understood that a couple things. First, in determining that we were losing coastal wetlands at the rate of a football field an hour, we used data, and that was the basis for the revelation about 30 years ago that the state was losing its coast probably as rapidly as any place on the planet. And second, that habitats could indeed be restored if they received sufficient sediment and fresh water. Data is indeed the basis for the 2012 Louisiana Master Plan for Coastal Restoration. It permits the state to model and project coastal conditions under dozens of different management response scenarios and rates of sea level rise. The USGS is one of many state and federal agencies that collects, disseminates, and interprets data for use in decision making. The USGS is the science arm of DOI, and these are the various groups that are part of the department's Geological Survey, the U.S. Geological Survey, and our strategic plan there for each of these what we call mission areas. And we all adhere to a basic, meticulously written and enforced fundamental science practices policy which addresses data management and quality, not just the peer review of journal articles. That quality influences the way we monitor volcanic activity and seismicity, as Katrin will discuss later, and it is truly underpins all of the work that we do. We call it our fundamental science practices, and it's metadata standards and all of that are included in that policy. Finally, I want to talk about free and open data. U.S. data is free and open to the public for the most part. There's some of our energy work, there may be a proprietary nature of some of it, but it's generally rolled up in materials that is presented to the public and available to the public in many different forms. Let me end here with my favorite illustration of free and open data policy and its impact. The Landsat satellite mission, which is a cooperative endeavor of NASA and USGS, began about 1972. Currently, we have Landsat 7 and Landsat 8 on opposite sides of the planet at 705 kilometers above the Earth's surface, circulating in a polar orbit every 99 minutes. And we upload instructions so that it is continuously taking images and collecting thermal data on Landsat 8 for the land surface of the planet. I remember as a scientist at the National Wetlands Research Center having to pay $1,000 or more for one Landsat scene. And so we would pick, one spring scene and maybe another time of the year, and we were very limited in how we could use the data because it was so expensive. Most of the archive had never even been accessed by users because of the cost. But today, thanks to a free and open data policy that was implemented in 2008, look at the impact that that has had on the use of the Landsat data globally. And in 2012, a study was done of the impact of that free and open data on, in terms of its economic benefit, $2 billion in annual economic benefit. And that was mostly just looking at the U.S. benefit of the Landsat data. If you use Google Earth or these other host of the Landsat data, you'll know it's used daily in people's lives. And as a result of this decision in 2008 and the evidence of how it affected the use and the ingestion of that data for decision making globally, in 2015, last fall, the Group on Earth Observations, all of the satellite agencies around the world met, and this free and open data policy was determined to be, the most benefit in terms of as how agencies around the world delivered Earth science data. And the European Space Agency signed an agreement with our State Department in Washington last December to make the Sentinel data, their satellite data, that is real comparable, and give us a 5-day revisit instead of a 7-day revisit on our Landsat images globally. They decided to make it free and open data, free and open to the public as well. So it's had an impact globally in policy, but mostly I'd say at this point in terms of the direct benefit to decision making. So with that, I'd like to return it to you, Cassandra, and we'll go into these 3 different examples.